This is us. Jamie, Andy.
So I'm Jamie, I'm the front-end developer at NTS, so do all the usual front-end things as well as quite a bit of Node.js.
Mm-hmm. Yeah. My name is Andy. I work as the back-end engineer. I'm also responsible for the streaming infrastructure of the radio. So we work at NTS. NTS is broadcasting online since 2011. We have a studio in Dalston, which is our main base. We also have a few more studios in Manchester, LA and Shanghai. Plus we do a lot of external broadcasts from around the planet, really. We also do video, we do live events, a lot of branded experiences, all sorts of engagements around music and youth subculture, if you want. Yeah. Tonight we're going to speak about a special project which kind of brings various aspects together. Well, James is going to introduce you to that.
Yes, so we were given the chance to do a live video stream of Aphex Twin from Field Day. So he did a headline slot in Field Day. And for those who don't know Aphex Twin, he's one of the biggest electronic music acts of the last 3 decades or so. And it's all electronic music, consistent electronic, but it can be sometimes quite heavy, housey techno things, or sometimes it's ambient. But it's very electronic. And another consistent aspect to Aphex Twin is his artwork, his general style behind the artwork. And you can see from these ones, and these come from his earliest releases. That was an early single, I think, and this one, and some other more recent things. He likes to play around with his face and sticking his face in places where it shouldn't really be. And so he does this here. As you can see this here. We're going to just do a live video stream of this, and as the tech team, we wanted to do something with it as well. We normally have a video team who would manage all the actual video streaming of it, but we wanted to do something a bit more fun. And there's kind of 2 aspects that we were able to help out with on the run-up to the live video stream. And one was to help promote the actual live stream. The 2-3 weeks preceding it, we wanted to promote the event, and on actually a place to host the video for where we'd actually put the live video, and also where we would push information preceding the event. And the 2 things that we figured to do this with was with a website virus. So this was to aesthetically simulate a virus taking over our NTS website, and to sort of match Aphex Twin's aesthetic as well. He often plays around with sort of techy, glitchy sort of style of things that we can translate quite nicely into the front end of our website. And the second aspect was our teaser page, which was essentially just an Aphex Twin microsite for where we put the information and do the actual live video streaming. So for the virus, as I said before, he really loved to play around with his face and putting his and just sort of do a lot of face mapping. He was quite an early adopter of that, I think. And so we thought we would do the same with us. Something that we at the station do, we take a lot of photos, quite high quality photos of our hosts that come onto the radio, and we thought we could play with these, make the most of these high quality source images and just put Aphex Twin's face on them. So we did this with Node.js, built mostly in 3 libraries, or primarily in these 3. There's GIMP, which is just an image manipulation library. It's quite extensive, but also very easy to use. You can do things, play around with color and sizing and all. Just general image manipulation. GIMP manages that. And we had OpenCV and Faced. OpenCV is essentially just a toolkit for image manipulation and for video manipulation as well. You can do things with, you can use it to detect gestures in video, or as we used it, to detect faces and images. It did the brunt work for us. And Face was just a small library that just kind of wrapped around OpenCV, which we could hook into the Node.js environment really, really easily. I should say, as you can see from this line of code, this does all the face recognition. This is it. And all that you pump into it is an image buffer. It can be a file path, but the image buffer can just be read really easily from GIMP. GIMP has a method called read image from URL, and it gives you back an image buffer. So that's it. This is taking the image and it provides us the properties. The faces one being just an object representation or information on where the faces are in the image. And within each face, this is an array. Within each of these faces, we have the width of the face, the height, the XY coordinates of it, and an array of features. Features being the eyes within the images, the nose, or the mouth. And with this information, you can really do quite a lot with it when it comes to sort of face mapping. It's all really done. So the next image, this is Floating Point. It's one of our hosts. You can see what this comes back if you just draw lines, draw a square, and where on what that face library is given back to us. So the next step was to draw Aphex's face onto it. So we had a series, we had a selection of just Aphex twin faces that we were able to use. And we simply just need to scale down these source images, which might be 800, 1600 pixels wide or tall, and just scale them down to the actual face or to the face detected in the image. And GIMP manages that, and it's really simple to use function, just to find the width and the height of what you want the source image to fit into. And it does that for you. And then you take the source image, use the function Composite, and you just give it the XY coordinates of where to stick this face. And that's it, and then this is the done. So the end result was this. And you can see, yeah. So that was it. This is largely it done. Although we had host images where we had multiple people as well. So I thought, okay, I'll try it out with some multiple people as well, and then you get something like this. And the things to note really is that it's not, first of all, it's not 100% effective. You can see there's a couple of faces around here that are missing. I've managed to miss it. I don't really know why. Part of it, I think, is because his head's tilted to the side, so maybe that messes with the algorithm somewhat. I don't know, but this, it still worked predominantly well. It still did what we were trying to achieve. One thing to note as well when I tried doing it with the crowd is that we wanted to, when I initially did it, there was a real sense of uniformity in the faces, so we just applied a random rotation in each face, which just kind of slightly removes that. And we did it randomly, but you could easily have just taken the eye features that you detected and just determine the rotation from those two. It'd be really easy to do. And that was it. This was us face mapping faces onto our source images. It was quite a simple thing to do, but the next challenge we had was how to serve these to the front end.
Yeah. So we sort of experimented all that on obviously dev environment, and the next slide is sort of telling us how we sort of productionized it. In the NTS we use EC2, the EC2 container service, an Amazon product to host Docker containers and orchestrate them. For us it was the easiest to then also have this feature running in a containerized environment. How we did that is, it's easy. I don't going to show you the code, but the steps are simple. We took a sort of base node on Linux image. We had to install CMake because OpenCV is a C library. We got the source code of OpenCV. We built OpenCV with CMake, not make, and then the rest is just copy paste the normal node attributes or the node files into the image and have a run command that boots it up. In our case, it was PM2 that manages the node process. We then run it within our sort of backend cluster, and it's ready there to start churning over images. We made a little demo, which I try now to run.
Sorry,
it's going to be difficult, but we'll try. So we took the same image and we just run it in a Heroku environment, so it's the same container that we had before.
Choose one for
let me just. Oh yeah, that's the one. I got one.
There's that top one, yeah.
I think this is one that we also made earlier. So it's an image I took at the very beginning of the talk, so it's just a random few faces there. And we now, so we give that to the little app. And you can see it's not a racer.
I
have to submit as well. So it's also very patient. Can't see my mouse.
There.
It's really challenging me a little bit. Is it to the right?
Go to the left.
Oh, the left, yes. There we are. Click the button, yes. Yeah, so that was one of the main problems that we realized. It would never really much speed it, and it does take seconds. It doesn't take milliseconds. It does take several seconds to turn around. This might be extra slow now because Heroku also needs to wake up a bit, but there it comes. So it doesn't recognize everyone, but it's for what we wanted to do of showing sort of a virus that kind of takes over an existing thing. It didn't need to be perfect. So you can play that at home. The URL is shared somewhere later on in the talk, so you can take your mom's pictures and put them through. So we have now a working app, if you want, in Heroku or in our ECS environment. The next thing is really on how we integrate into our media service to make it a proper service that can serve images. This shows how NTS serves their images. So on the left we have we have a user with a computer in the browser. It goes through a CDN. In our case we use CloudFront from Amazon. Then we have a service that's running Nginx, and we use the image filter library to resize the images to various sizes. So we have a large size, a medium, and a small, and so on. And the source images that really live in S3, where they're stored. And so the next thing is how we're going to extend that to have our little Aphex images being served. So that's how we did it. This is how we did it. This is not how we should do it, but I'll take you through. So we just open up a second route. This, in reality, was really the same service. It kind of, again, it sizes the images because they need to be sized to the same, large, medium, small. And then instead of going to the static images, it goes to this replace and says, I have this ID of the image, I want this manipulated with this Aphex thing. Then this face replacer can't handle very large images, so he has to get the resized medium-sized one. So he goes back to the front, requests the medium-sized image, and then it churns it through. It takes several seconds, and eventually, bang, it goes to the front. That was great. It worked well, because once the cache is warmed up, it doesn't matter what happens in the back, no? But what we realized, especially when there's new images, the whole thing got just bombarded with many calls that took several seconds to fulfill, so the whole thing just fell apart quite easily. So what we should have done is really, as soon as an image gets loaded in, we should have sent off a message that then pre-processes this image and stores the manipulated image as well alongside the existing one. So we learned around sort of decoupling things a little bit. But it kind of got us through. I think the next slide is...
So that was us serving an Aphex image is what we're calling it. So we had to just tie this into the client-side code, really. So this is the recently added section of the website, where all the recently added shows come through. And I simply just took the source image URL from all of these, just using jQuery, and I just amend the URL to have a path name of Aphex in it. And that puts it into the Aphexer. And that's us now got the images. So we had to, and then all I had to do is swap them around, but we needed to preload them on the client side before we did that, as the stutter between switching them around would be really visible. You just get a black frame, and it kind of ruins the effect. But once we preloaded it, it would just look like Aphex's faces were just getting drawn all over the place. And so we would randomize this. We wouldn't randomize it. We would stutter it, so that you would just see his face flashing. And on the 3 weeks before the event, we would just do it a little bit. So it would kind of catch your eye a little bit, and you think you saw something there. You weren't really sure, and then a couple of days before the event, we would have it really take over, and it's really just sort of possessing the website. And this is sort of yeah. So that was that aspect of it, and the next was we created an Aphex Twin font. So just as a regular font, the Universe font, but we added some Aphex Twin URLs, and we also swapped around the lowercase and the uppercase. This just contributed to the really sort of glitchy nature of how it would appear. So when you saw it on the website, it would just kind of look something like that. This is just the fonts for now anyway. When this was mixed in with the actual face replacement, it kind of took over. And the final part of the sort of Aphex Twin virus was to do, it was just a flashing page on a home page. This is a stupid photo anyway, but it becomes worse when you got that happening all the time. And so when you come on the home page, we just flash this for people who are arriving on the website. And again, as before, we sort of slowly released this in the 3 weeks preceding the event, where it would just happen quickly, and you're not sure if you saw it. And then it happens. And all of this, all of the settings for how quickly we would flash things in, or the probability that someone would arrive on the website and see it, was all configurable in real time.
Mm-hmm. Yeah, so we wanted, that's the wrong place now. We wanted to sort of control how this flashing works. Partially we weren't quite sure how the servers hold it up. They didn't hold this up so well. But also we wanted to sort of control the user experience, and we didn't want to do that with deploy and rely them to sort of refresh the page. So we used Firebase database as an option store. And you can see you kind of started with a bit less variables that we control, but the main one is the probability. -1 means it doesn't happen, so there's no phase replacing. As soon as you put 0.1 in, then there's a very small chance that you get that. And then we also made a time window of how long you show the Aphex image and how long it may happen until we show the Aphex image, or how long we're going to show the original image again. And so combined with the probability, that started sort of being really quite random. And we this is basically then replicated across the other two variables, which is the font and the overlay. So the whole thing was sort of throwing it quite nicely around. And every now and then we noticed that our backend servers, because of this quite imperfect way of caching the images, got under stress. Then we just switched quickly off again and let it calm down a bit, and then sort of bring it up and just keep warming up the cache. And once the cache was really warmed up, then you could turn it up fully. Here, I just have a small code example how simple that is to access the Firebase database for those who haven't done it. So the starting point is you have to get a Firebase library into your client-side JavaScript, which is just a script tag and a source. And then you have to initialize the app, which is the top bit up there. Config is just a bunch of secrets and tokens and names that connect to that specific database. And then the loading, which happens then at the point wherever you want to sort of access the database, you reference the options table or namespace, and you use the once take a snapshot of this data, and in the callback you can then call value and assign that to your options variable, and then you do stuff based on that. And the idea is that you sort of might do that quite frequently, so the client is updating itself with the latest options. So if I'm sitting in the office and change the options, I want this propagated quite quickly in all my users across the globe when they sort of click around the website. Yeah.
And with that was the Aphex virus complete. So then we moved on to the next part of the project, which was the teaser page, the Aphex Twin mini site. And this was it. This was it just before we released the live video. So there were various stages. So it became the live video eventually, but this is what it was beforehand. And we had this countdown, which we tried to keep quite cryptic. And as the time went on, we added the dates and the actual location of what it was. But the first time we put this website out, all it was the countdown and this little input box. So the countdown here, it doesn't actually go down linearly. It would speed up closer to the actual event, and this is just a way to sort of further obfuscate what the countdown was, because the Aphex Twin fans are really quite committed to it. And they were really trying to figure it out. We could see it online. It was a lot of fun, and then we just added some other things in here. You can see the little text scrambler actually spells out Aphex Twin as it goes through as well. It's just trying to, again, he's just sort of just creating this sort of glitchy aesthetic. And the second part of all of this was this little input box, which does deliberately didn't really do much, or there wasn't much information on what it was. But this is what it would do, and rather cruelly, this is all it would ever do. It would say error. And I remember when I made this, I was sort of thinking, I wrote the code for the success message anyway. So if you look in the JavaScript and the HTML, it's possible there's code in there to handle a success message, but the displaying that success message was dependent on a property from a callback, which I knew would be undefined. So basically, I knew it would always be false. So we would display this, and I thought I was crazy for doing it, but people picked up on it straight away and were talking about it on Reddit and the Aphex Twin forums and things. So yeah, it's a bit cruel. Well, it was cruel, but we were doing something with this data, and we were actually collecting what everyone was typing here and sending it off to a data store, and people were. Yeah, it was just interesting looking back at it. A lot of people were saying a lot of political things, a lot of comments on Donald Trump. There was a lot of people just trying to guess the passwords, giving Aphex Twin's real name, his album names. At one point, in fact, whilst we were squashing the Git code to hide it, people went through our Git history, and we're extracting old commit code and putting it in there, trying to see if this would work. It was really, really deep. And that was on the first day of releasing it. People were doing that as well. People were straight on it. So we were collecting all this information, and what we were doing with these passwords was collecting it all to later use during the actual video stream of the event, which I want to elaborate on.
Yeah. So I'll give you a quick rundown as well on how we hosted this page as well, or this mini site as well. Here we were a bit more prepared, so we knew that we're going to get a huge spike of traffic just at the moment when this live stream is going to happen. So we knew we wanted to be in a sort of highly scalable world if we want. And we also knew that in a way it doesn't need a server. It's a static bit of website. So we choose a serverless architecture, static. We choose to deploy it to GitHub pages, but we could have easily just stuck on S3 or anywhere else. We kind of like the simpleness and the tools in GitHub, and we wanted to open source it anyway. So that's why I went. We did use Firebase database again to collect the data, the password submissions. Again, because it's just a very nice library, it's very simple to code. So if you see where we initialized the database in the previous code sample, the next thing there is just to do a post, call a method post with the payload, and it's all done for you. Probably the interesting bit is that you have a bunch of rules, which is sort of the authorizations that you have against your data store. And that, to be honest, took us a little time to really read it all in detail and get it right. So we had a few attempts where people kind of did stuff with it that we didn't really foresee, but we learned. So you can see that stuff is nice with J. So you can see the messages, which basically is the array or the index of all the messages. So we didn't allow any read or write on that for that particular user, which is just one user for all the web pages, because it's just one token that everyone has the same. Every user has the same token. But then on the sort of row level, so each message, we allow people to write in if it got it right. And then we also started validating the data a little bit, because we got annoyed with people putting this kind of codey stuff into our data store, and we got confused about it. So we kind of cut it down to 100 characters and said it's always a string. So once we got that right, it was really reassuring that you can really lock it down. It's very easy to understand what the public can interact with the data store. So that was really a nice experience using that. I'm going to do it again.
And so, really just to finish off is to show you the actual video stream, or at least a segment from it. It's 2 hours long, but we come through. Is it Domino? That's not part of it, but
yes.
Yeah. So you can see here, close here, all this is taken from a video. So on the front end, rather than putting the countdown into that little terminal I made on the teaser site, I just pumped through all the passwords that we collected. And with that, no, I can't. With all that data, so we recorded the screencast. We recorded it for about an hour. It would have went on for much longer. We recorded around an hour of it, and we gave that to the video team. So they just had this little video sample of this terminal clicking, and throughout this clip, you can just see they just use it to decorate the entire thing. And if you look closely, you can see you probably find a couple of emails in there as well. We tried to take them all out, but they're in there. And yeah, this was kind of the finish. This was like the end of the project. This was the grand finale of it all. Yes. So all the code for this is on GitHub. And we wrote a little Medium article as well, just talking about what we've spoken today if you want to get any more details on it. But thanks for listening.